Hello everyone. Okay, for our last exercise in chapter 12, and let's be honest, our last exercise for this whole semester, other than revision, will be exercise 12.9 on log laws. So building on our previous lesson last lesson we looked at understanding logs and working out how logs and indices are sort of related together. Today we're going to have a look at some laws, the way things logs sort of behave. Now, if you want to understand why these log laws happen, then please feel free to ask me that in class. I might even run a little session with people who want to know. But otherwise, all you need to do is know how to handle these and how to actually manipulate them so that you can find things that are useful. In fact, that's all that maths is really, just manipulating things so that they become more like things that you know. Therefore, you can crunch them down quicker and easier to find solutions. So, drilling down to these log laws that we've got, I think we're going to look at sort of 5 of them today. The first one, if you have, there's some conditions with this, it must be the same base. You've got A, and there mustn't be any number except for the number 1 outside of the log. So that there is an invisible 1, and that there is an invisible 1. If it's any other number, this won't work. Okay, so if there's a 2 or a 3, which you might see a little bit later, no, not there. If you see, say, 2 log A of x plus log A of y, you can't add those two things together unless you do something with this 2, which I'll show you a little bit later. But you can't add those two. It simply won't work. Okay, so let's just go back to the one we've got. The conditions are that the bases need to be the same, and the numbers outside the log are the same, and they are in this case. If those things are true, then this law, these two things, when you add them together, become log A of x times y. Okay, so when we add logs together, we multiply the numbers inside the logs. Okay, all of these laws come from the indice laws. So you'll see lots of similarities with the types of things that we're doing. When you have the same logs, log base A, one minus from the other, guess what we need to do? That becomes log A of x divided by y. Okay, when we add them, we multiply. When we minus or take away, we divide. Okay, we don't divide the logs. It doesn't become log A of x divided by log A of y. That's something completely different altogether, and we'll have a look at that a little bit later. It's just the log A of one term divided by the other term. Okay, something else that can be quite useful is that if we've got log A of x to the power of n, what we can actually do is we can move this n out the front and multiply it by the log. So like this, that can become n times log A of x. Okay, and we can actually go for all of these rules so far, we can actually go from the left to the right, or from the right to the left. It really doesn't, there's no sort of right and wrong, it's just depending on what we like, which one is going to be most effective for us. Okay, so I mentioned up here, in this question over here, I said, what if we had 2 log A of x plus log A of y? How would we work that out? Well, first we'd have to do this, make it log A of x squared plus log A of y. Now, once this one here from there to there is using this rule. Now, once we've got them, when there's the a's are the same and the numbers are at the front are the same, then we can multiply them. So that becomes log A of x squared multiplied by y. And I'd prefer you to put brackets around this, otherwise I don't know whether you want to include the y in the log or whether you're just multiplying the whole thing by y as well. So make sure you always use brackets. I just that was a little bit of a tangent, but I think it might be well worth looking at anyway. I'll rub it out for now though. If you'd like to have a look at it, you can write it down yourself. Okay, so the 4th rule that we're going to look at, if we remember what logs are, we ask ourselves, what do I have to raise a to the power of to get to a? Well, that if I turn this into an indice, that becomes, I'll just use that as x for the moment. It's a, as in the base a, to the power of x equals this number here, which is a. That number there is a 1. So therefore, x equals 1. So the rule is, if you've got the base and the number exactly the same, the answer will always be 1. Now, this one over here, let's just have a look at that for a second. I'm going to call that x. So a to the power of x equals 1. Okay, just rearranging it. The only time that this will ever be true is if, actually two conditions, if a equals 1. But actually I don't really want to sort of focus on that one for the moment. Let's just pretend that a is not 1. The other time that this can happen is if x equals 0. Anything to the power of 0 equals 1. So log anything of 1 will equal 0. Okay, and that's the rule that we need to remember. So there are the 5 rules that we will be using and learning about and manipulating in the exercise 12.9. Let me just show you a quick couple of examples just so that you can sort of get your head around it. This one here can be done in 2 ways. You can do them separately, log 2 of 16 plus log 2 of 4, add those 2 things together and find out the answer. Or you could, when you're adding logs, you multiply, and so you can get the answer that way. I'll do them both ways. I'll do the blue as using the log laws, and then the red without using the log laws. So that becomes log 2 of 16 times 4. Now if you remember what that is, that's log 2 of 64. And what do I have to raise 2 to the power of to get to 64? That is going to be, let's just do it over here, 2 to the power of x equals 64. So 2 to the power of x equals 2 to the power of 6, I believe. So therefore, that answer should be 6. Okay, that's using the log laws. Let's use it without. Log 2 of 16, what do I have to raise 2 to the, 2 to the power to get to 16? That's a bit of a tongue twister. That becomes 2 to the power of 4 equals 16. So the answer, that log there equals 4. And this log here, what do I need to raise 2 to get the power to 4? My goodness. The answer will be 2. Okay, 2 to the power of 2 equals 4. So 4 plus 2 equals 6. Same answer. It works. It's probably easier to do it this way, I think. Or at least it will be more consistently. The next question here, log 3, 81 divided by 27. A little bit tricky, this one. I think I'm going to use my log laws to get it into something that I like a little bit more. So that because there's a divide inside the log, not one log divided by the other like the next question. Okay, very different things, those 2 things there. Okay, but this time I've got 81 divided by 27. I'm going to turn that into log to the base 3 of 81 minus log to the base 3 of 27. Sometimes we go left to right, like with these rules up here. Sometimes we go left to right, other times we go from right to left. In this case I've gone from right to left just to make it easier for myself. There's really no right or wrong, it's just a matter of which one is most convenient. Now, log to the base 3 of, 3 equals 81. What do I have to raise 3 to the power of to get to 81? Well, I'm going to say that is 4. You can do that using the odd switcheroo log to indice thing if you want to, but I just know that it's 4. And here, that's log to the base 3 of 27. I know that one. That's that will be 3. So the answer to this question is 1. Okay, let me just check this on a calculator just to make sure. Log to the base 3 of 81 divided by 27. Yes, the answer is 1. Perfect. It works. Either my calculator is wrong or we're both right. So finally, the last question. Now, with logs, you cannot cancel the logs in any way. Okay, you can't divide one log by the other. People will be very tempted to just cross out that and cross out that because they're the same. But they are in fact not the same at all, because one of them is to the power of 5 and one of them is to the power of 2. And let me just be really clear. It's not log 3 all to the power of 5. That can happen as well. That's not what we have. We've actually got log 3 of 3 to the power of 5. So the power is actually in there. And I probably should have put brackets around those just to sort of signify that. Okay. I mean, this one can also be written as 3 to the power of 5 as well. There's nothing wrong with that. And in fact, that's what I'm going to do. So this one becomes log 3 of 3 to the power of 5 over log 3 to the power of 2. That one then becomes, I'm going to use the I think it was the third rule, which says if you've got a power, you can bring it out the front. So, and multiply it. So that one becomes 5 times log 3 of 3 over 2 times log 3 of 3. Now, remembering that this one here, I can do this two ways now. Log a of a, so log 3 of 3 will be 1, because log a of a is 1. So this one here is equal to 1, and that one there is equal to 1 as well. So I could just write, cross that out and put 1, and then cross that out and put 1. So 5 times 1 over 2 times 1, which is 5 over 2. But I guess what I want to do is, because these are exactly the same now, log 3 of 3 and log 3 of 3, we can actually divide the bottom, and the top by log 3 of 3. Because they are exactly the same, we can divide them. Kind of like if I've got, say, let me do the actual numbers, 5a over 2a, I can say that those two a's will eliminate themselves and I'm just left with 5 over 2. That's what I can do here. But I can only do that if they are exactly the same. So don't be tempted to do that at other times. So either way, that and that one will disappear. That becomes 5 over 2, and that is my final answer. I think we're done. I think we're done for the whole course, actually. There's plenty of things you probably need to revise and remember and all that sort of thing, and you've still got to do some exercises in 12.9, but we are done for the teaching content of this course. Well done, and enjoy the rest of the revision and the study that goes along with that. See ya.